Hello everyone. Today I want to talk about the last point that I want to say about hypothesis test. It's about p-value. The reason why I didn't mention p-value before is that uh, if you take a look at the notes above, we from sampling distribution to confidence interval, we are pretty familiar with with the use of z-score, right? So we are pretty familiar with z-score, so it's easier to understand how to reject or accept a hypothesis using z-score. However, p-value is just like eventually you will have the same result when you're using z-score or p-value. P-value is more like a reverse engineering of z-score. um, it approach the hypothesis test from a different angle, and I will explain it in detail here. So if you take a look at the description of p-value, it seems pretty confusing, right? Um, so I will walk you through how to work with p-value to do hypothesis test. First, first thing first, you need to know that p-value is, what does P stands for? P stands for probability. So p-value is a probability. And if you're using p-value to do hypothesis test, the only criteria to reject or accept a hypothesis is this. You will reject the non-hypothesis if p is smaller than alpha. If you could remember, what is alpha? Alpha is your chosen level of confidence. If you remember what we talked about in confidence interval section, for example, we want a 90% confidence interval, we want a 95% confidence interval, or 99% confidence interval. In those scenarios, your alpha could be 10, 5, or 1%. So the alpha is your chosen level of confidence. Now how do we get B? Let's draw our old friends here, the same old graph, the graph of sampling distribution. However, this time, the mu of this distribution, mu 0, this is a hypothetic value. This is the value you want to test. And for example, you have a sample. It gives you the mean of the sample is right here. And let's just say you are doing a two-tailed test. So as we mentioned before, a two-tailed test has two sides on the graph. So you have a sample here, which gives you a mean like this. Therefore, you should also, because it's a two-tailed, so you should also have a value here. Let's just call it. You should also have a value here. And they are symmetric according to the mu 0. Then what is the p-value? The p-value is just the area of this. It's just the size of this area. Why p-value is that? And why can we reject the non-hypothesis if p-value is smaller than alpha? If you recall how to construct a confidence interval, For example, if we want to construct a 90% confidence interval, then our alpha is 10%. And let's just say this mu0 is the real mu. And this is the sample we got. So if you construct a confidence interval, let me change the color here. It may look like this. A 90% confidence interval. And if you could recall what I have been explaining to you, a 90% confidence interval structured around the sample mean you got is essentially the same as a 90% confidence interval structured around the population mean, which is the mu. So therefore, you can say if your level of confidence is 10%, which is 90% confidence, the alpha is 10%. Alpha represents the area of this region. In this case, the alpha is smaller than the p-value. Therefore, we cannot reject our hypothesis here. What does it mean is that if the mu0 is our true population mean, everything could make sense. However, if it's not our true population mean, let's draw another graph. If the mu0 is here, the sample mean you got is too far from mu. Here's another value for two-tailed test. This is the p-value. And this is your 90% confidence interval. And this area is alpha. You can see alpha is bigger than p. Therefore, you should reject the null hypothesis. Therefore, the true population mean cannot be this. So now I hope you get a sense of what does p-value mean. P-value is essentially saying that if your hypothesis is true, and if you have a sample mean, based on these two conditions, how confident can you be? Let me rephrase it. If you have a sample mean, how confident can you say that the true population mean is the same as your hypothetic value? If you are 99% confident, that represents that the p-value is only, if you are 99% confident, that only represents the p-value is only 1%. However, if you want an alpha to be 10%, you have to reject your hypothesis because you are too confident. You have considered almost all the possible scenarios to get the same result as your hypothesis. In a sense, we don't want to be too confident. We only want the confidence level that we can accept. So that's essentially about p-value. When you are solving questions about hypothetic tests, I strongly recommend you to stick with the z-score as it's easier to comprehend. If you're using p-value, maybe you could get confused about which area you are referring to in the graph. So that's what I want to say about p-value.